Hello friends, in this tutorial we will learn how to evaluate some mathematical expressions. See this workspace, there are some variables already generated in MATLAB. We will see it later on. Now if we want to evaluate 2 raised to 5 divided by 2 raised to 5 minus 1, then how can we evaluate? For that we have to write this expression. This gives the value of this expression. Now if we want to find square root of any number, then we can find it as this way: square root of 9. We got 3. What if we have some expressions as an argument? Let's write square root of pi I square minus 3 divided by 2. So what happens? See what happens. It evaluates. So in this case, what it does, first it evaluates the expression inside the round bracket, and that value will be passed as an argument to this function square root. And in this way we can find the value of any function. So in MATLAB, if we have to give argument, then we can give argument in an expression format also. What if we are having radius as a expression? Let's say r is equal to pi I raised to 1 upon 3 minus 1. The value of r is this. You can see that we have assigned expression to the variable r, and that expression is evaluated and assigned to r, and value of r is shown on the command window as output. What if we don't want it to be printed on command window and just define that value and store it in variable r? For that we have to use semicolon, and output will not be shown on the command window. We will see for the area. So we have already calculated the radius of circle. Let's say A is equal to area of a circle is equal to pi I r square. For that we have to write caret 2 and just semicolon. See, we haven't in earlier case we haven't added a semicolon at the end of expression. In this case we have added expression, and the output of variable a is not shown on the command window, but it is here. Earlier I have done this expression, so variable is already in command window. Let's change the radius of circle. R is equal to pi I square, and see what happens. Radius is changed. Now evaluate A. Area of circle is evaluated, and see the change in the value of variable A. This is the way we can evaluate this expression. Now what if we want to evaluate the exponential? For that we have to write exp, an argument in round bracket, this way. This gives the value of exponential, so it is the value of e power 3. What if you want to find natural logarithm of e raised to 3? For that we have to write ln exp whose argument is 3, and close the brackets. Oh, it is not accepting the natural logarithm as ln. It has inbuilt function log for natural logarithm. So write this expression. It gives 3. You can see that log and exponential eliminates each other. What if you want to find logarithm with base 10? For that we have to write log 10 and pass the argument 10 raised to 5. This is easy for us to see whether it works or not, because log 10 of 10 raised to 5 gives us the value 5. So let's check, enter. Yeah, our answer thought and a value of this expression are same, so it's working. What if we want to find a exponential with some power as a expression, like e raised to the power pi under root 163. For that, write this expression exp as argument. What is the argument? Pi I multiply by square root of 163. So close this bracket. So what will it do? 163 is given as an argument to the square root, so it will calculate square root of 163 and will be multiplied with the pi, and the value of this expression will be given as an input to the exponential. It will find the value of exp. Let's put here semicolon. No output on the command window, but see here, answer is stored at this variable answer, this. Now store that value to z. Assign z here. It will calculate value of this expression and will store here. Now see what is the value of z. This is the value of z.